Welcome back everybody. This is we were having our lectures on the binomial theorem and its applications, and this is the second lecture in the series. In the last class we had discussed in detail about what exactly is the statement of the theorem and how we came up with it. So, the statement of the theorem is as follows: x plus y whole to the power n is n choose 0 x power n plus n choose 1, that many number of y's you are picking, x power n minus 1 times y plus n choose 2 x power n minus 2 y squared. So, you are choosing 2 y's and remaining x's. Then you are choosing 3 y's and remaining n minus 3 x's. And this sequence, this series goes on and on till you end up with n choose n minus 1, and then you choose only 1 x and n minus 1 y's, and lastly you choose all n as y's and no x's at all. Okay. So, this is the binomial theorem, right. Now, this we had proved, we had developed intuitively. You can also prove it with the method of induction, etc. Now, n choose 0, n choose 1, these are all from combinatorics, that is n choose r. I hope you know the combinatorics. It is factorial n by factorial r and factorial n minus r, right. So, this is the definition of n choose r. Okay. So, this is the statement of the theorem, and this I did just as a very brief recap. Now, some of the very interesting properties, and a lot of these are coming just from the fact that these are combinatorics, right. One of the properties is that the first term n choose 0, this is the first coefficient, and the last coefficient n choose n, these are equal. Why is that? Why is n choose 0 equal to n choose n? That is because factorial n by factorial 0, that is 1, by factorial n minus 0, that is factorial n. So, that is equal to 1, and n choose n, it is again factorial n, and here you have factorial n and here you have factorial 0. So, it is the same result. Then the next result is that n choose 1 and n choose n minus 1 are equal. Why is that? Because here you have factorial n, factorial 1, factorial n minus 1. The other one you have factorial n minus 1, factorial 1. So, these are mirror images of each other, right. In other words, you could have just as well written the whole thing as y plus x whole power n, right. Instead of writing it as x plus y whole power n, you could have also written it as y plus x whole power n, and all of those terms would have been reversed, right. So, obviously, the expression has to be symmetric, that is, the coefficients from one side have to be equal to the coefficients from the other side. Okay. Let us take a look at exactly what I mean. So, suppose these are my coefficients from this side, and I have these as my coefficients from the other side. Then this 0th one will be the same as the nth one, number 1 will be the same as n minus 1, number 2 will be the same as n minus 2, and so on, right. They are all going to be mirror images of each other, exactly equal to each other. So, if n happens to be odd, for example, if you are dealing with x plus y whole cube, right, you know what happens, you get 0, 1, 2, 3, that is it, something into x cube plus something into x squared, and then something into x, and then something something into y cube. So, these two are equal and these two are equal, right. So, there are two terms in the middle. So, you have got 0, 1, 2, 3, these two are terms in the middle, they are the middle terms. But suppose, so we know these coefficients, you know them just by the way. Suppose you were doing x plus y whole power 4, right, what would happen? You would get x power 4 times 1 plus 4 times x cube y plus 6 times x squared y squared plus 4 times x y cube plus 1 times y power 4, right. This is your n choose 0, n choose n, n choose 1, n choose n minus 1, right. And here the two coincide, the middle term is there is only one term in the middle, right. Okay. So, this is just an observation. The next observation is that the sum of these powers is always equal. So, you are doing x plus y whole power 4, this is 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, and y power 4. The sum of those powers is the same throughout. That is another observation. Okay. So, like this, let us try to do some more, let us come up with a few more results. So, when I write C 0, it actually means n choose 0. So, suppose someone asks you a question, what is this sum, n choose 0 plus n choose 1 plus n choose 2 all the way till n choose n. How will you do it? These are all the coefficients of x plus y whole power n. Suppose y is equal to 1 and x is equal to 1. So, let us plug in y equal to 1 and x equal to 1. What do you get? You get x power n is 1, x power n minus 1 is 1, y is 1, y power n is 1. So, you get all of these terms, right. Net result is this sum is equal to what? 1 plus 1 whole power n. Okay, thank you. This is a good first exercise. Try another one. Let us make x equal to 1 and y equal to minus 1. 1 minus 1 whole power n. What will you get? What is 1 minus 1? 0. 0 power n is 0 obviously, right. So, if x is 1, y is minus 1, then x plus y whole power n has to be equal to a big 0. Okay. So, 0 is equal to n choose 0 1 to the power n plus n choose 1 1 to the power n minus 1 times y, y is minus 1, plus n choose 2 1 to the power n minus 2, which is 1, times y power 2, y is minus 1. Okay. And now you group things together, you put all the minuses on one side, all the pluses on the other side, or you need not do all of that. So, you can just simplify this and say that this is n choose 0 minus n choose 1 plus n choose 2 minus n choose 3. So, it keeps alternating, right. Is that okay? This is fine? Okay. So, there are of course two cases over here. One case is when n is even, the other case is when n is odd. So, let us quickly think about them very quickly, right. If n is even, let us simplify, let us do it all the way till 2 power n. Sorry, 2n, right. 2n is always even. So, instead of doing x plus y whole power n, let us do whole power 2n. Okay. So, this is equal to 0, we know that, and that is equal to 2n choose 0 minus 2n choose 1 plus 2n choose 2 and so on and so forth, right, plus 2n Cn, fine. And then you bring the even terms to one side, the odd terms to the other side. So, you get 2n C0 plus 2n C1 plus 2n C2, sorry, 2n C2n. This whole sum will be equal to 2n C1 plus 2n C3, all the odd terms on the other side. Okay. So, on one side I have kept the odd terms, on the other side I have kept the even terms. And now tell me something, what is the sum of all these coefficients, all of the coefficients, what is the sum? What is the sum of all the coefficients? From our earlier result, what is the sum of all the coefficients? It is 2 power the exponent, right. In this particular case our exponent is 2n. So, the sum of C0, C1, C2, all of these, the sum all the way till 2n is 2 to the power 2n, right, and some of them, that is half of them, this and so on, are equal to the sum of the others, right. You have split it into two parts, they are both equally heavy, but the sum of them is equal to 2 power 2n. So, what is each? Each of the sets are 2 power 2n minus 1, each of those sets. So, C0 plus C2 plus C4 okay. This is another very interesting result that we came up with, and all of this we are getting just by plugging in some numbers at random right. It might seem like I am plugging these numbers in at random, but these are nice results to get. Okay. Let us try one more. Another result, another very popular result is the following. Okay, this is a very popular result, and let us attempt to derive this. How will you do this to start with? How will you think? So, on the right hand side, what you see is 2n Cn. What do you think this means? By the way, these are all should have been NC0, NC1. Okay. 2n Cn means that I probably have to do something to the power 2n, right. I have to work out something whole to the power 2n. What could it be? I want to work something out, some x and y whole power 2n, right, and the middle of the coefficients, the middle coefficient of this expansion x plus y whole power 2n, that coefficient is 2n Cn, right. I want to find out this middle coefficient, and then this middle coefficient has to be what you have to do is you have to show that the middle coefficient is equal to the rest of the stuff. How will you do it? How will you do it? The rest of the stuff is to the power n, right. You are choosing out of n in the rest of the terms. So, clearly those terms you are going to deal with something plus something to the power n, right. So, think about it, the way we are going to do this, and you will get this with some practice. Okay. We are going to look at something like x plus 1 by x whole power 2n, and further we are going to find out the coefficient of the term which is independent of x, which does not have an x in that particular expansion. So, let us try it out first. So, x plus 1 by x whole power 2n. Now, the middle coefficient is obviously this, right, and the middle coefficient is not just the coefficient, it is the middle term, because when you break up x plus 1 by x whole power 2n, right, and look at the term right in the middle, you get something nc0 x power 2nc0 x power 2n plus 2nc1 x power 2n minus 1 times 1 by x, etc., right. The term in the middle is 2n Cn x power n times 1 by x power n, and these two politely cancel out. Okay, that is the term in the middle, and then of course you have many more terms, 2n Cn 2n minus 1 x 1 by x to the power 2n minus 1, and lastly 2n C 2n 1 by x power 2n, right. You have got many terms in this expansion, but there is only one term which does not have an x in it. That term is the middle one. Okay, it is the complete term. That term does not have x in it, it is independent of x. Okay. Now, is there any other way of breaking up x plus 1 by x whole power 2n? Any other way? Yes, there is. You could break it up as x plus 1 by x whole power n times x plus 1 by x whole power n, right. And how do you do x plus 1 by x whole power n? NC0 x power n plus NC1 x power n minus 1 times 1 by x plus NC2 x power n minus 2 times 1 by x squared, and so on. This is the first expansion, and the next expansion is, okay, let us modify this a little bit. I will not write it as x plus 1 by x power n, I will write it as 1 by x plus x whole power n. Okay, I am playing some tricks. So, what is the expansion of the second term? The expansion of the second term is again NC0 times 1 by x whole power n plus NC1 times 1 by x power n minus 1 times x plus NC2 times 1 by x power n minus 2 times x squared plus dot dot dot. So, you see why I did that, right. You see why I did that. I did that because these two are going to cancel out with each other when you multiply them, right. They will cancel out with each other, right. Now, what are we looking for? We are looking for the term in this entire product which is independent of x, right. If I multiply x power n with anything else, let us say I multiply this term with this term, some x remains, okay. It is not going to be independent of x. The only way it is going to remain independent of x is if I multiply this term with the one right below it. So, NC0 x power n times NC0 1 by x power n, multiply them, it is independent of x. The term on the top times the term in the bottom, independent of x, term in the top times term in the bottom, independent of x, and so on and so forth, the way I have written it up. And clearly, therefore, the term which is independent of x is nothing but NC0 squared plus NC1 squared plus NC2 squared dot 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 all the way till NCn 1 by x power n and NCn x power n. That is what was there. Okay. So, NCn squared, and therefore, I have proved it. So, this is an elegant way of proving this complicated result, right. NC0 squared plus NC1 squared, there is hardly any other way to all the other, I mean this is not a very trivial result. This requires a lot of thinking, a lot of hard work to come up with this without the binomial theorem. Okay. This is fine. A lot of people use these results as standard ones. Which ones am I talking about? NC0 plus NC1 plus NC2 plus dot dot is equal to 2 power n. A lot of people use this as a standard result, and this C0 plus C2 plus C4 is equal to, so all the even terms, sum of all the even terms is equal to the sum of all the odd terms, which is equal to 2 power 2 n minus 1, right. This is a standard result, and the same here, this is also a standard result, NC0 squared, NC1 squared, NC2 squared, the sum of these is equal to 2 n C n. Yet another standard result which is very similar to this result, very similar. Okay. So, we are going to look at a more generalization, of the earlier identity that we saw. So, what we are going to do is, so the identity is as follows: C naught C r plus C1 C r plus 1 plus C2 CR plus 2 plus dot 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 plus Cn minus R Cr, and you have to show that this is equal to 2n C R plus n, which is equal to factorial 2n by factorial r plus n and factorial n minus r. Okay. So, this is what you have to show. How do we do this? This is just notice that if I plug in r equal to 0, I get back the earlier one. If I plug in r equal to 0, then I get back the earlier one, that was C0 squared plus C1 squared plus C2 squared plus dot 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 all the way till C. Oh, I think this should be n, Cn squared, and that will be equal to 2n Cn is equal to factorial 2n by factorial n by factorial n. Okay, so, this is the same new identity, is just a generalization of the older one. So, a special case, plug in r equal to 0, you get back the original. Okay. So, the older one, how did we solve? Just recollect, we plugged in, we tried to do the term independent of x in the expansion of x plus 1 by x whole power 2n. Okay, that is what we tried. Now, this time I am not going to try x plus 1 by x, I am going to try x plus y. So, let us try an x plus y. So, this, remember, this is the identity that we are looking forward to. What I am now going to do is, you are looking for this as your answer, 2n C r plus n. Now, if you look at x plus y whole power 2n, then this is going to expand as x power 2n C0 times x power 2n plus C1 times x power 2n minus 1 times y plus dot dot dot. So, which term will be 2n C r plus n? Which one are you looking for? For example, x power n y power n will be a term inside this, and that will have a coefficient of 2n C n. Okay. But that is not 2n C n plus r. So, this is not it, right. If I look at the next term, then it is 2n C n plus 1, and then the power of x decreases by 1 and the power of y increases by 1, right. This is also not it, right. The one we are looking for is 2n C n plus r x to the power n minus r y to the power n plus r. Okay, if you do this expansion, it expands into many terms. This is just one of the many terms. These are all terms inside that. Now, this term happens to be our answer. Okay, the coefficient of this term. So, the binomial expansion, this binomial expansion is not the only way to expand this, right. Maybe you can also expand it as x plus y whole power n times y plus x whole power n. Now, why did I flip it? You will soon see why I flipped it, right. It is not totally obvious, but I have flipped it for now. In one case I have written x plus y, in the other case I have written y plus x. This is just my magic. Okay. So, what can we do? We are looking for the coefficient of x power n minus r times y power n plus r in the expansion of x plus y whole power n times y plus x whole power n. That is our plan. So, let us rephrase the question. What is the coefficient of x power n minus r times y power n plus r in x plus y whole power n times y plus x whole power n? This is our question. Now, there are many ways to break up x power n minus r times y power n plus r. Okay, many ways to break it up. Let us say you want let us say I borrow y power n from here, from this side, then from this side I will have to look at x power n minus r times y power r, and always remember the sum of n minus r and r, the sum of these two has to be equal to n, right. So, just cross check. So, x plus y whole power n will have a term x power n minus r, y power r. What is the coefficient of that? N C r. And what is the coefficient of y power n in y plus x whole power n? N C n. Okay. Then let us decrease this by 1, and so suppose I look for y power n minus 1 times x, and on this side, oh I am sorry, this will be n c 0 because you are looking for no x's. Okay. So, y power n minus 1 times x times x power n minus r minus 1 times y power r plus 1. Now, what is the coefficient of x power n minus r minus 1 times y power r plus 1 in x plus y whole power n? And the answer is n c r plus 1, right. How that is the number of y's you have chosen. And what is the coefficient of y power n minus 1 times x in y plus x whole power n? You have chosen only one x, so it is n c 1. Then you could also have chosen y power n minus 2 times x squared, and you could have chosen on this side x power n minus r minus 2 times y power r plus 2. Okay. So, the product of these two is once again x power n minus r, y power n plus r. So, what is the coefficient of y power n minus 2 x squared in y plus x whole power n? You have chosen 2 x's, so it is going to be n c 2. And what is the coefficient of this one? X power n minus r minus 2 times y power r plus 2. You have chosen r plus 2 y's, so this is going to be n c r plus 2, right. So, like this you can keep constructing things. So, let us write it down. So, this will give you n c r times n c 0. The first term. So, this is a shortcut, you may or may not write the n. Sometimes writing C0 is the same as writing NC0. A lot of times this is implicit. Okay. So, in the question papers, for example, a lot of times they just omit the n. So, at that time do not get totally shattered and distressed about it. So, this n can easily be omitted. It is implicit in the expression what it is, what they are talking about. So, what we have got over here from the product of these two is this first term, plus the product of these two gives me, this is NC1 and this is NCR plus 1. So, that is the second term, correct. So, like this you are going to keep going and then you are going to go till y power so the y's are tracking over here. So, C1 C2 all the way till Cn minus r, y power r x power n minus r on this side, right. If I have y power r on this side, I need y power n on the other side, which means I will have x power 0. So, how many x's, sorry, how many y's have you chosen over here? You have chosen n c n y's, and on this side how many x's have you chosen? It will be n c n minus r. So, the last term gives you n c n n c n minus r. So, the sum of all of these terms is 2n c n plus r x power n minus r y power n plus r. All right. So, this is a complicated identity, but it sometimes turns out to be useful. All right. Now, we are going to try to solve some problems. So, I have a prepared list of problems, a few problems that I have prepared, and then as and when you ask me more problems, we can solve them. So, this is my question 1 and I have a question 2. Okay. And then I have a question 3. Okay. So, this is my set of questions, 3 questions. What is the coefficient of x power 7 in this complicated expression? Second question, what is the coefficient of x power minus 7 in this other complicated expression? And the third question is, what is the relation between A and B, if these two answers are the same, that is the coefficient of x power 7 and the coefficient of x power minus 7 in those two terms, in those two expansions. If they are equal, then what is the relationship between A and B? So, these are my 3 questions. Let us try to solve this. Okay. How will you solve? Expand, right, binomially expand the first one. Let us say, let us try to do the first one. a x squared plus 1 by b x whole power 11. So, you start from 11 C 0 a x squared whole power 11, right. Clearly, this is not going to give you x power 7, okay, plus 11 C 1 a x squared whole power 10 times 1 by b x. What is the power of x in this term? So, x power 20 minus 1. So, x power 19. So, the first term gave me x power 22. The next term is giving me x power 19. So, let us observe what happens. What will this give me? So, this one is giving me 22, this one is giving me 19. What is this giving me? X power 18 minus 2. So, that is 16. It is not 7 as yet, right. Where will I get 7? 11 C 3 will give me x power how much? 22, 19, 16. I will get 13, x power 13 over here. Then 11 C 4, what will I get? X power 10. 11 C 5, I will get, what is the power of x? 12 minus 5 will give me 7, right, and then the remaining ones will keep going down further. So, the only term that is giving me x power 7 is this one, and clearly the coefficient of x power 7 is therefore going to be 11 C 5 times a power 6 by b power 5. All right. Great. This is my answer to question 1. Then let us try question 2. What is in my question 2? A x minus 1 by b x squared whole power 11. Slightly twisted, there is a minus as well. Okay. And 11 C 0 a x whole power 11. What is the power of x here? 11. Very good. Minus, because there is a minus here, what is the power of x here? X power 10 minus 2. So, that is x power 8. So, here I have 11, here I have 8, then the next one is going to be a plus 11 C 2 a b, right, and then I will get x power 5, not what I want x power minus 7. Next one is going to be 11 C 3 and there I will get x power 2. Next I will get (11 C 4) and there I will get x power minus 1. Next 11c5 and x power minus 4, and then I will get 11c6, and then let us write this out completely, ax whole power 5 1 by bx squared whole power 6, and examine it carefully. I have got x power 5, I have got 1 by x power 12. So, 5 minus 12, I have got x power minus 7. So, it satisfies my requirement. So, what is the coefficient? So, this is the term I am looking forward to, and therefore, the answer to my question 2 is 11c6 a power 5 by b power 6. Just by the way, 11c5 and 11c6, what are these? What is 11c5? Factorial 11 by factorial 5 factorial 6, and what is 11c6? It is the same thing. Okay, so, they are equal. So, then look at my third question. What is the relation between A and B if the first answer is the same as the second answer? If the two coefficients are equal, what is the relation? 11c5, obviously that is already equal to 11c6. So, I do not have to do anything. All that I am saying is a power 6 by b power 5 is equal to a power 5 by b power 6, which means that a is equal to b. A is equal to 1 by b or b. So, let us multiply by b power 5 . Yeah, A is equal to 1 by b. Great. Okay. So, that is the answer to my third question. So, this is just a practice problem. Okay. One more practice problem. Respectively. So, this problem statement says a and b are the coefficients of x cube in 1 plus x plus 2 x squared plus 3 x cube whole power 4 and 1 plus x plus 2 x squared plus 3 x cube plus 4 x power 4 whole power 4 respectively. Okay. Then okay. This is a trick question, a very tricky question. How will you solve it? How will you solve it? This is a very tricky question. Think about it. You might not need the binomial theorem at all, right? All you need to do is think a little bit. After all, the binomial theorem is nothing. It is just a way of putting things together. So, if you apply the same way to put things together, you can always keep that in mind, that n choose 0, where did that come from? I split up my x plus y whole power n into n terms, and then from some I am taking x, from some others I am taking y, right. and then you make that product. So, if you think like that all the time, then all of these problems can be very straightforward. Okay. Think about it. What do we do here? 1 plus x plus 2 x squared plus 3 x cube whole power 4. What is that? This is a very big sum, right? It is not x plus y whole power 4. What will you do? You want to split it up into 1 and the rest? Okay. That is a possibility. Let us not do it. Let us not do it that way at all. Let us think of it as follows. The coefficient of x cube. How will you get the coefficient of x cube? Let us do some accounting. Okay. How will you do it? You can pick the 1 here, the x here, x here, x here, that will give you x cube. You can pick 1 here, x squared here, x here and 1 here, that will give you x cube, right. You can, so basically you can pick the 1, you can pick the x, you can pick x squared also sometimes, but if you pick x cube over here, then the remaining 3 have to be equal to 1, because you want x cube. Okay. So, you do your variety of things, sometimes you pick 1, sometimes you pick x, sometimes you pick 2 x squared, sometimes you pick 3 x cube. If you pick 3 x cube from any one of the terms, then the other 3 terms have to be 1, right. Okay. So, that is A. So, you do all of this accounting and get A, all right. You want to do it? Okay. How many ways can you pick a 1? So, we are going to do 1 from here, 1 of the 4 terms will be 1 and 3 of these. Okay, let us do it like this. X cube, you can have 1 x x x, you could have it as 1 x squared, 1 x squared and x, right. You could have it as 1 1 1 and x cube. Okay. If any of the terms is x cube, the remaining 3 terms have to be 1. How many ways can you pick x cube? I can pick this one, I can pick this one or this one. 4 choose 1 ways to pick the 3 x cube term. Right, 4 choose 1 ways to pick the 3 x cube term, right. All the other terms have to be a 1. Okay. Then suppose I pick one of the terms as x squared. So, there are 4 choose 1 ways to pick the x squared. And then from the remaining 3 terms, I have to pick an x. All right. And then, so that gives me the x squared x, that kind of a setting. And then the third is x, x and x. Instead, you can say how many ways can I pick 1, because the remaining 3 have to be x. So, 4 choose ways to pick, 4 choose 1 ways to pick an x. So, this is A, right. You work this out, this is your coefficient A. Likewise, you have to work out B, but guess what? B has an extra 4x power 4 term, and that should never come in x cube. You are never going to pick 4x power 4. So, it is irrelevant, is not it? So, you are saying that to get B, you add this, which you are never going to pick, right. You are always going to choose your terms to construct x cube. You are always going to choose your terms between these 4. You are never really going to go to 4x power 4. You are never going to pick it. So, B is also going to be the same, which means that A minus B is nothing but 1 0. Okay. So, this was a tricky question. Actually, you did not really have to compute this. I computed this just for fun. You do not have to do it. This was just done as a as an exercise, right. The principle of doing this is the same as the binomial theorem, but we are working with a much larger problem, right. So, term by term you look at it, think about it carefully and work it out, you will get this answer. Okay. So, I think we are going to stop here for today, and we are going to proceed from this in the next class. We are also going to look at some other properties, some generalizations of the binomial theorem in the next class. Okay. Thank you.